Good morning. So now we continue the LED. So high internal efficiency of LED designs. We know that that graph is that the difference of the luminous efficiency of AIGANP double heterostructure LED emitting at 565 nanometer on the active layer thickness. So the figures revolves the optimum active region thickness 0.15 to 0.75 micrometer. So the radioactive recombination probability needs to be increased and non-radioactive recombination probability needs to be decreased. And high carrier concentration in the active region achieved through the double heterostructure design improves the radioactive recombinations. Therefore, R equal to B and P. So the DH design is used to all the high efficiency designs today. And high internal efficiency designs doping of the active region and that of the cladding region strongly affects internal efficiency. So therefore active region should not be heavily doped as it is causes carrier spill over into the confinement regions, decreasing the radioactive efficiency. So doping levels of 10 power 16 or low 10 power 17s are used or none at all. So p-type doping of the active region is normally done due to the larger electron diffusion length. So carrier lifetime depends on the concentrations of majority carriers. So in how acceleration regime, so the radioactive carrier lifetime decreases with the increasing free carrier concentration, and hence efficiency increases with doping at high concentrations. Dopants induced effects acting as a recombination centers, and that this is a display p-n junction displacement. And already we know that the secondary mass spectrometry SIMS profile of Zn in gallium Indian arsenide phosphate and Indian phosphate double heterostructure. So the structure uses Zn as a p-type dopant. Part A shows number of p-n junction, no p-n junction displacement. Part B shows the p-n junction is a displacement caused by high Zn doping of the upper gliding region. So the displacement of the p-n junction causes significant change in the internal quantum efficiency in a DH LED structure. So dopants can redistribute due to the diffusion, segregations or drift. So doping of the confinement region is that difference of the luminous efficiency of AGANP is a double heterostructure as a LED emitting at 560 nanometer on the N type confinement layer doping concentration after that this one. So resistivity of the confinement regions should be low, that heating is minimal, and high p-type concentration in the gliding region keeps electrons in the active region and prevents them from diffusing into the confinement region. So electron leakage out of the active region is more served than the hole leakage. And non-radioactive recombination, so the concentration of defects which cause the deep levels in the active region should be minimum. So also surface recombination should be minimized by keeping all the surfaces several diffusions length away from the active region. So measure LEDs and layers which where the meso edge exposes the active region to air, they have low internal efficiency due to the recombinations at the surface. So surface recombinations also reduce the lifetimes of LEDs. And lattice matching, is the optical output in intensity of an helium arsenide LED driven within the injections current of 20 milliamp versus the lattice mismatch between the AI and GAP is active region and that gallium arsenide substrate. So the carrier recombined non-radioactively at mismatch dislocations. Density of mismatch dislocations lines per unit length is proportional to lattice mismatch. So hence the efficiency of LED is expected to drop as the mismatch increases. and a high extraction efficiency structures. So shaping the LED die is critical to improve their efficiency. So however, cost increases with the complexity. And then efficiency structure is tip LED employs advanced LED die shaping to minimize internal loss mechanisms, and tip LED is high power LED, and then luminosity efficiency exceeds 100 IM by watt. And the visible spectrum LEDs, the plot charts the grains made the luminous efficiency till date. And then the emission of spectrum of blue, green, and red and LEDs indicates that the green LED has the wider spectrum. Thank you. See you next class.